Tool center point setup. The course content will be 1. Setup of TCP. 2. Application scenario of TCP. 3. TCP calibration. The course duration should be around 20 minutes and the course goals are able to create a TCP and 2. Be familiar with the scenario of TCP and the typical application. First, we'll go through the setup of the tool center point. The advantage of TCP. First, it's very convenient for us to teach points when we need to adjust the robot pose. In a case we don't have a TCP, the robot can only teach around the center or end flange. While the actual tool position might be different after teaching and requires a reteach, we could easily solve this with TCP. By setting up different TCP in the program, we could shift the movement path. Third, to let the robot move in a linear around relative to the TCP, the typical application with a 2D vision. Before we start learning TCP, let's look at the end flange TCP. This is the default position for TCP of the robot and its parameter cannot be modified. The origin of the end flange is at the center of the end flange. The opposite direction of the end tool I/O connector is the positive direction of this TCP. The Z positive direction of this TCP is from the center of the end flange towards its outside. The X positive direction of the flange is defined according to the right-handed screw system. Make the gesture as shown in a picture. Point your index to the Y positive direction and the middle finger to the Z positive direction. The X positive direction of the TCP will be the thumb pointed. Besides the end flange TCP, JAKA robot also provides 10 more editable tool center points. As shown in the right picture, in the TCP settings of operation setting, we could set up the TCP wanted. There are 6 parameters. In the first 3 parameters are the offset dimensions of the new TCP, comparing to the end flange, while the last 3 are pose parameters, the pose of the new TCP comparing to the end flange TCP in Euler angles, in case of the new TCP pose in the same with the end flange. Those parameters are 0, 0, 0. If you want to set up a new TCP, there is basically 3 methods for that. 1. The manual input. 2. The 4-point settings. 3. The 6-point settings. During the next slides, we are going to see in detail these 3 methods. First of these 3 methods, input settings. Comparing the new TCP and the end flange TCP, calculate the offset value of the dimension and pose orientation. Then you can input the results in each of the white rectangles. The second method, the 4-point setting. Find a fixed position as a reference within the robot reachable range. Set those 4 points with different pose while the robot should aim at this reference point at all positions. After setup of those 4 points, click confirm. The software will calculate the TCP parameter automatically. Now let's watch the video. In the TCP setting in general setting, click the edit icon. In a case of high accuracy is not required, we could input the TCP parameters directly. For example, 200 on the Z axis. Then you can click confirm. For the 4-point settings, select and set up the first point. Then you can adjust the robot pose and set up the second point. Adjust the robot pose and set up the third point. When it's done, you can confirm and adjust for the robot for the fourth point. Click Confirm after setting those 4 points. The robot will now calculate the parameters for this TCP automatically. In Manual Operation screen, change the TCP as the new TCP. Then, teach the robot pose. Let the robot rotate around the new TCP endpoint. The third method, 6-point setting. This method is based on 4th-point method, adding 2 more points for the tool pose calculation, similar with the user coordinate system setting. The 4th point is the origin of the tool center position. The 5th point is the little upper toward the TCP Z axis. The 6th point is any point in the plane combine of Z, O, X. Okay, now let's have a look on the video of the 6-point settings. In operation setting, click Edit, select 6-point setting. Set up the previous 4 points as the same we saw with the 4-point settings. Then you can set up the 5th point. This point is in the Z axis of the tool. In the Z direction is along with the 4th point and the 5th point. Then you can set up the 6th point. This point is any point in the plane combine of Z, O, X. After the setup of all the 6 points, click Confirm. The software will calculate all the unknown parameters automatically. Then, in the manual operation page, we could teach the robot with this new TCP. Make the robot moving along with the negative direction of Z axis. Comparing with the 4-point setting, the software calculated the robot's pause automatically. Let's go through the cautions for the tool setup. First, in case of absolute accuracy not required, we could create a TCP roughly instead, as long as it's easy for teach. Second, in case of exigent scenario, such as a collaboration with a 2D, 3D camera, or the robot must move in a perfect straight or circular path, we'll need to create a precise TCP. Third, during creating a TCP with the 4 points method, we need to ensure that the tool end is pointed to the top of a point from all angles. The result could be not accurate enough while the offset is just within 1 mm for one out of 4 points. Fourth, it would be difficult to create a precise TCP with the 4 points method if we don't have the correct tool and target, such as there is no pinpoint on a tool or it's not sharp enough. Fifth, regarding the judgment of the TCP accuracy, after creating the TCP, take a reference object with a pinpoint. Let the pinpoint on TCP rotate around the object pinpoint by large margin, rotate plus or minus 180 degrees. Observe that if these 2 pinpoints are always attached during a posture change. 6. In case of the TCP is not accurate enough, manual compensation is provided. Method referred to the last page of this document. Consult JAKA technical support if necessary. Last one, if the user is familiar with a skilled operation, 5 minutes will be enough to create a precise TCP for one robot. Application with the TCP programming. The first set TCP instruction. This is for creating a new TCP. With clicking this instruction, you can directly input the TCP position and pause parameters. With the second set TCP instruction, we could select the N flange or the other 10 TCP created in the settings. Relative linear motion with TCP. In the relative linear motion, we could select the reference coordinate system as the TCP wanted. By clicking the relative linear motion, you can access the window where you can select the coordinate system you want to use. Application. Pick up with a 2D vision. The first one is the original position of the product. The second one is the position moved. The second position is offset 100 mm each in X and Y direction from the first position. And the RZ rotation is 30 degrees. Robot programming. First, set the TCP as an end flange. Join move to the position which is 100 mm above the pickup point. Relative linear move downward 100 mm. Wait for 1 second. Move upward 100 mm. Relative linear move 100 mm in the X-axis direction. Turn the TCP 30 degrees in the Z directions. Then move downward 100 mm with a relative linear motion. Wait for 1 second. Move upward 100 mm. Change the end flange TCP to TCP1 and repeat this operation. In this application, programming the robot first, then use the end flange TCP and the new TCP for relative movement. Run the program. The position will be offset in the case of using the end flange TCP after linear and rotate motion. By using the new TCP, the robot will reach the position specified. Now, let's watch the video about this application. Part 3. Method for TCP calibration. First, set up the parameters of the TCP with the 3 method provides. There might be some slightly offset. Second, make the tool endpoints to a fixed sharp point. Adjust the robot pose to RX 180, RY 0. The end of the robot points to the ground with this pose. Let the robot tool end rotate in RZ direction with the world coordinate system. The Z parameters of tool will not affect the tool end point during rotation, means ignoring the effect of the tool Z parameter. Third, rotate the tool 180 degrees in RZ direction. There will be some offset between the tool end and the fixed pin point below. Check the X offset of the tool end in the end flange coordinate system. The offset is caused by the X parameters of the TCP. The compensation will be half of the X offset. The compensation shall be negative of the measured result, such as when the measured X offset is positive 2 mm in the end flange TCP comparing the origin before rotation. The compensation of X parameter should be 1 mm. Fourth, adjust the Y parameter with the same method for X compensation in step 3. Fifth, the step 3 and 4 can be repeated, depends on the results. Sixth, rotate the tool in a RZ direction after compensation. The offset will normally under 1 mm. Robot arm accuracy should be considered if excessive. Note that calibration method is effective with the TCP X and Y parameter only. Z and rotation excluded. That's all for the TCP setup. Thank you for watching.